November 15, 1943, 0530 hours, Betio Island, Tarawa Atoll, Gilbert Islands. The pre-dawn darkness hung heavy over the coral reef, broken only by the distant rumble of naval bombardment that had been pounding Japanese positions for hours. Lieutenant Commander Shibasaki Keiji of the Imperial Japanese Navy's 7th Sasebo Special Naval Landing Force crouched in his reinforced concrete bunker, confident that the Americans would face the same fate that had befallen every other amphibious assault against a heavily fortified atoll. What Shibasaki couldn't know was that he was about to witness the debut of an American innovation that would revolutionize Pacific warfare and render obsolete every assumption about coral reef defense. The Americans had just solved the mathematical impossibility of landing heavy equipment directly onto coral atolls, and the psychological shock of this revelation would shatter Japanese defensive doctrine across the entire Pacific theater. The strategic situation in the Central Pacific during late 1943 represented a critical juncture in the American island-hopping campaign. Japanese defensive strategy relied heavily on the natural barriers presented by coral reefs, which historically had made amphibious assaults against atolls nearly impossible. Traditional landing craft required deep water approaches and sandy beaches, limitations that the Japanese had exploited to create seemingly impregnable fortress islands throughout their Pacific empire. Intelligence reports consistently indicated that American forces would be forced to wade hundreds of yards through shallow reef waters under withering defensive fire, making successful amphibious operations prohibitively costly. The Japanese had spent months fortifying Tarawa's approaches, constructing interlocking fields of fire that covered every conceivable landing beach. Their defensive calculations were based on decades of naval warfare experience, which demonstrated that landing craft could not navigate coral reefs without sustaining catastrophic damage. Previous amphibious operations in the Pacific had reinforced these assumptions, as American forces had been forced to rely on rubber boats and swimming assaults when facing coral barriers. The stakes at Tarawa were enormous, as success or failure would determine the viability of the entire Central Pacific offensive strategy. The development of American amphibious capabilities represented one of the war's most significant but underappreciated technological achievements. Beginning in 1941, American naval architects and marine engineers had recognized that traditional landing craft would prove inadequate for Pacific operations. The challenge was not merely one of navigation, but of physics and engineering. Coral reefs presented multiple obstacles. Their irregular surfaces could tear hulls apart, their shallow depths prevented conventional craft from reaching shore, and their sharp edges could trap vessels at low tide, leaving troops exposed to enemy fire for hours. American shipyards responded with unprecedented innovation and production capacity. The landing vehicle tract, or LVT, emerged from collaboration between civilian engineers and military planners who understood that Pacific victory required revolutionary amphibious capabilities. These vehicles combined the characteristics of boats and tanks, featuring tracked propulsion systems that could traverse both water and land, armored hulls capable of withstanding small arms fire, and shallow drafts that allowed navigation over coral reefs. Production statistics revealed the scale of American commitment. By late 1943, factories in Louisiana, California, and Michigan were producing over 500 LVTs monthly, with quality control standards that ensured mechanical reliability under combat conditions. The technical specifications that made this possible represented engineering breakthroughs that Japanese intelligence had failed to anticipate. Each LVT weighed approximately 18,000 pounds, but drew only 30 inches of water when fully loaded, allowing navigation over reefs that would ground conventional landing craft. Their Continental W670 engines provided sufficient power to maintain 7 knots in water and 20 miles per hour on land, while their tracks distributed weight evenly to prevent coral damage. Most critically, their aluminum hulls incorporated design innovations that allowed them to absorb impact without catastrophic failure, a capability that Japanese defenders had deemed impossible. The human element behind American amphibious superiority reflected broader advantages in training, education, and organizational effectiveness. American crews underwent extensive training programs that lasted months rather than weeks, learning not only vehicle operation but also navigation, maintenance, and combat tactics. Training facilities in California and North Carolina replicated Pacific conditions, allowing crews to master reef navigation before facing enemy fire. This contrasted sharply with Japanese defensive preparations, which assumed that environmental barriers would prevent effective amphibious assault regardless of crew quality. American forces approaching Tarawa possessed advantages that extended far beyond individual vehicle capabilities. The logistics network supporting amphibious operations included specialized repair ships, spare parts inventories, and fuel distribution systems that could sustain operations thousands of miles from home bases. This logistical superiority meant that mechanical failures could be rapidly addressed, maintaining operational tempo that Japanese defenders could not match. The psychological preparation of American forces also differed significantly, as crews had trained extensively for the specific challenges they would face, rather than hoping that environmental factors would prevent enemy success. The mathematics were undeniable when comparing American amphibious capabilities with Japanese expectations. While Japanese defensive planning assumed that landing forces would require 45 minutes to traverse reef areas on foot, American LVTs could complete the same journey in under 10 minutes while providing armored protection for their occupants. This time differential transformed the tactical equation, reducing exposure to defensive fire by over 75%, while simultaneously delivering heavier weapons and more troops to contested beaches. The statistics told a story of technological revolution that Japanese intelligence had failed to comprehend. The morning of November 15th revealed the full extent of American innovation as the first wave of LVTs approached Betio's coral barriers. These vehicles carried not only Marines but also flamethrowers, mortars, and ammunition supplies that traditional amphibious assaults could never have delivered intact. Their ability to transition seamlessly from water to land operations meant that beachhead establishment could begin immediately upon landing, rather than after the lengthy and vulnerable reef crossing that Japanese defenders had planned to exploit. The technical specifications revealed a level of engineering sophistication that reflected American industrial superiority. Each vehicle incorporated over 15,000 individual components, manufactured to precise tolerances, assembled by skilled workers who understood that mechanical reliability could determine battle outcomes. Operational reality demonstrated advantages that extended beyond mere transportation. LVTs could provide direct fire support during beach assaults, using their mounted machine guns to suppress enemy positions while simultaneously delivering troops to assault positions. Their armored hulls offered protection against small arms fire that had proven devastating to previous amphibious operations, while their tracked propulsion systems allowed navigation through terrain that would immobilize wheeled vehicles. Most significantly, their ability to retract from beaches and return for additional loads meant that supply operations could continue under fire, sustaining offensive momentum that had previously been impossible to maintain. The enemy response revealed the psychological impact of encountering capabilities that contradicted fundamental assumptions about amphibious warfare. Japanese defensive doctrine had been predicated on the vulnerability of landing forces during reef crossing, and the sudden appearance of armored vehicles traversing coral barriers created immediate tactical confusion. Radio intercepts captured the bewilderment of Japanese commanders as they attempted to understand how American forces had solved what they considered an unsolvable problem. Defensive fire that had been carefully planned to target vulnerable infantry found itself directed against armored vehicles that absorbed damage and continued advancing. Lieutenant Commander Shibasaki's own account, captured in his final radio transmission, reflected the broader Japanese shock. Enemy vehicles are crossing the reef directly. This was not anticipated in our defensive preparations. They are landing heavy weapons and continuing to advance despite our concentrated fire. This transmission revealed not only tactical surprise, but also the psychological impact of witnessing the impossible made real. Japanese defensive planning had invested enormous resources in fortifying against anticipated American limitations, and the sudden obsolescence of these preparations created strategic confusion that extended far beyond Tarawa itself. The personal accounts of American LVT crews revealed the human dimension of technological superiority. Corporal James Mitchell of the 2nd Marine Division recorded his experience. "We expected to take heavy casualties crossing that reef like everyone said we would. Instead, we rode right over it like it was a road. The Japs kept firing at the water where they thought we'd be waiting, but we were already on the beach setting up our mortars." This account illustrated how American innovation had transformed not only tactical possibilities, but also the psychological experience of amphibious assault. Technical personnel provided detailed explanations of the capabilities that made this transformation possible. Chief Petty Officer Robert Hansen, responsible for LVT maintenance, documented the engineering solutions. These machines were built to take punishment and keep running. The tracks could handle coral that would tear up boat hulls, and the engines had enough power to push through surf that would swamp regular landing craft. We'd practiced this 100 times in training, but seeing it work under fire was something else entirely. Strategic assessments from American commanders revealed their understanding of the broader implications. General Julian Smith, commanding the 2nd Marine Division, noted in his post-action report, "The LVT has fundamentally altered the mathematics of amphibious warfare. Islands that were previously considered impregnable due to coral barriers can now be assaulted directly. This capability provides strategic options that did not exist 6 months ago." This assessment proved prophetic, as subsequent Pacific operations would rely increasingly on amphibious capabilities that Japanese forces could neither match nor effectively counter. Enemy perspectives, documented through captured materials and post-war interviews, revealed the devastating impact of American technological superiority. Colonel Takeshi Yamamoto, a staff officer with the Japanese 31st Army, wrote in his diary, "The Americans have solved the reef problem that we believed would protect our island fortresses. Their vehicles cross coral barriers as easily as we cross dry land. Our entire defensive strategy must be reconsidered." This acknowledgement represented more than tactical surprise. It reflected the broader realization that American industrial capacity had produced capabilities that Japanese forces could not replicate. Japanese technical personnel struggled to understand the engineering principles that made American success possible. Captain Hiroshi Nakamura, an engineer with the Imperial Navy's construction forces, recorded his analysis. "Examination of captured American vehicles reveals manufacturing precision and material quality that exceeds our capabilities. The track systems alone require metallurgical expertise and production capacity that we cannot match. This is not merely a matter of design, but of industrial superiority. This assessment highlighted the connection between American manufacturing capabilities and battlefield effectiveness. Post-war interviews with Japanese commanders provided additional perspective on the psychological impact of American amphibious innovations. Admiral Keizo Komura, who had overseen Pacific defensive preparations, acknowledged, "We had calculated that coral reefs would provide natural barriers that no amphibious force could overcome efficiently." The American solution to this problem demonstrated industrial and engineering capabilities that we had underestimated. Our defensive planning became obsolete overnight. Civilian observers and war correspondents documented the broader implications of American amphibious superiority. Robert Sherrod, correspondent for Time magazine, witnessed the Tarawa assault and reported, "What I saw today changes everything about Pacific warfare. The Americans didn't just overcome Japanese defenses, they made them irrelevant. Coral reefs that were supposed to be barriers became highways for American armor." This observation captured the transformational nature of American technological achievement. Intelligence officers analyzing the strategic implications recognized that American amphibious capabilities represented more than tactical innovation. Colonel William Donovan of the Office of Strategic Services noted, "The LVT program demonstrates American ability to identify strategic problems and develop technological solutions at industrial scale. This capability provides options for Pacific operations that Japanese forces cannot counter effectively." This analysis proved accurate, as subsequent operations would exploit American amphibious superiority to accelerate the Pacific Campaign timeline. Local populations affected by these operations provided additional perspective on American capabilities. Native inhabitants of Pacific islands consistently reported their amazement at American equipment and logistics. One Marshallese witness described American operations. "The Americans brought machines that could travel on water and land. They had so many supplies that they gave away food and equipment that would have been precious to the Japanese. This showed us who would win the war." The manufacturing scale that supported American amphibious operations revealed industrial superiority that Japanese forces could not match. American factories produced over 18,000 LVTs during the war, with peak production exceeding 500 units monthly. These vehicles were manufactured at facilities in Louisiana, Michigan, and California, employing over 50,000 workers who had been trained in specialized assembly techniques. Quality control systems ensured that mechanical reliability remained high despite rapid production schedules, with failure rates under 3% during combat operations. Comparison with Japanese production capacity highlighted the disparity in industrial capabilities. Japanese shipyards struggled to maintain production of conventional landing craft, managing fewer than 100 units monthly while facing critical shortages of steel, aluminum, and skilled labor. Their attempts to develop equivalent amphibious vehicles were hampered by material shortages and limited engineering expertise, resulting in prototypes that could not match American performance standards. The mathematics of production revealed American advantages that extended far beyond individual vehicle capabilities. Raw material availability demonstrated American resource abundance that Japanese forces could not replicate. Each LVT required approximately 8 tons of aluminum and steel, materials that were readily available to American manufacturers, but critically scarce in Japan. American supply chains could deliver these materials from domestic sources, while Japanese production depended on increasingly vulnerable shipping routes from occupied territories. This resource disparity meant that American production could accelerate while Japanese capabilities declined. Transportation and distribution networks supporting American operations reflected logistical superiority that multiplied tactical advantages. Specialized shipping designed for LVT transport could deliver vehicles directly to forward bases, while maintenance facilities established on captured islands ensured operational readiness. This logistical infrastructure meant that American amphibious capabilities could be sustained indefinitely, while Japanese defensive preparations remained static and increasingly obsolete. The innovation pipeline that produced American amphibious superiority demonstrated institutional advantages that Japanese forces could not match. Research and development programs involved collaboration between military planners, civilian engineers, and industrial manufacturers who could rapidly translate concepts into production reality. University partnerships provided theoretical expertise, while corporate resources ensured practical implementation. This collaborative approach produced continuous improvements based on combat feedback, ensuring that American capabilities evolved faster than enemy countermeasures. Testing and refinement processes reflected American commitment to operational excellence that exceeded Japanese standards. LVT prototypes underwent extensive evaluation under simulated combat conditions, with design modifications implemented based on performance data rather than theoretical assumptions. This empirical approach ensured that deployed vehicles met operational requirements while maintaining mechanical reliability under stress. Japanese development programs, constrained by resource limitations and time pressures, could not match this thorough approach to capability development. Continuous improvement based on combat feedback demonstrated American organizational advantages that multiplied technological superiority. After-action reports from amphibious operations were systematically analyzed to identify performance issues and potential enhancements. Design modifications were rapidly implemented in production lines, ensuring that later vehicles incorporated lessons learned from earlier operations. This feedback loop meant that American capabilities improved continuously, while Japanese defensive preparations remained based on obsolete assumptions. The immediate tactical changes resulting from American amphibious capabilities transformed Pacific warfare in ways that Japanese forces could not counter effectively. Traditional defensive strategies that relied on coral barriers became obsolete overnight, forcing Japanese commanders to develop new approaches without adequate resources or time for implementation. The ability of American forces to land heavy weapons directly on contested beaches eliminated the vulnerability period that had previously characterized amphibious operations, fundamentally altering the tactical equation. Enemy doctrinal adaptations revealed the broader impact of American technological superiority. Japanese defensive planning had to account for the possibility of direct amphibious assault against any coral atoll, dramatically increasing the resources required for effective defense. This strategic burden exceeded Japanese capabilities, forcing commanders to choose between inadequate defense of many positions or concentrated defense of few. The mathematics of resource allocation favored American offensive operations that could exploit Japanese vulnerabilities created by their inability to defend everywhere effectively. Cascading effects on other military systems demonstrated how American amphibious superiority influenced broader strategic calculations. Japanese naval aviation had to be repositioned to counter amphibious threats, reducing support for other operations. Artillery resources were diverted to coastal defense, weakening defensive capabilities elsewhere. Most significantly, the psychological impact of American amphibious capabilities undermined Japanese confidence in their ability to defend Pacific territories, contributing to strategic paralysis that affected all aspects of their war effort. Training and deployment changes required by American amphibious capabilities exceeded Japanese adaptive capacity. Effective defense against LVT assaults required new tactics, specialized weapons, and extensive training that Japanese forces could not provide. Their attempts to develop countermeasures were hampered by resource constraints and the rapid pace of American operations, which prevented systematic implementation of defensive improvements. This adaptation failure meant that Japanese defensive effectiveness declined even as American capabilities continued to improve. Strategic realignment resulting from American amphibious superiority accelerated the Pacific Campaign timeline in ways that Japanese planners had not anticipated. Islands that were expected to require months of siege warfare could be assaulted directly, reducing the time required for strategic advance. This acceleration created operational tempo that Japanese forces could not match, forcing them into reactive positions that played to American strengths while exposing Japanese weaknesses. Resource allocation changes reflected American ability to exploit amphibious superiority for maximum strategic advantage. The success of LVT operations justified increased production and deployment, creating positive feedback loops that enhanced American capabilities while straining Japanese defensive resources. American commanders could plan operations with confidence in their amphibious capabilities, while Japanese defenders faced uncertainty about their ability to counter American innovations effectively. Timeline acceleration created strategic options that had not existed before American amphibious capabilities matured. Operations that would have required extensive preliminary actions could be launched directly, reducing warning time for Japanese defenders while maximizing surprise advantages. This operational flexibility allowed American forces to exploit intelligence opportunities and tactical advantages that would have been impossible with conventional amphibious capabilities. Allied coordination improvements resulted from standardized American amphibious capabilities that could support multinational operations. British, Australian, and other Allied forces could integrate with American amphibious operations, multiplying the strategic impact of American technological superiority. This coordination capability provided options for simultaneous operations that overwhelmed Japanese defensive capacity while demonstrating Allied unity and effectiveness. The psychological warfare impact of American amphibious capabilities extended far beyond immediate tactical effects. Japanese morale suffered as supposedly impregnable positions proved vulnerable to direct assault, while American confidence increased with each successful operation. The demonstration of American technological and industrial superiority undermined Japanese propaganda claims about American weakness, while reinforcing Allied determination to achieve complete victory. Morale impact on both sides reflected the broader implications of American amphibious superiority. American forces gained confidence from their ability to overcome obstacles that had previously seemed insurmountable, while Japanese defenders faced the psychological burden of defending against capabilities they could neither match nor effectively counter. This morale differential influenced combat effectiveness in ways that extended far beyond the immediate tactical situation. Propaganda value and exploitation of American amphibious capabilities provided strategic advantages that Japanese forces could not counter effectively. Newsreels and photographs of LVTs crossing coral reefs demonstrated American technological superiority to global audiences while undermining Japanese claims about the impossibility of amphibious assault. This propaganda impact influenced neutral nations and Allied populations, while demoralizing Japanese civilian morale. Enemy attempts to counter the psychological effect of American amphibious capabilities revealed the limitations of Japanese strategic communication. Their propaganda could not credibly explain how supposedly impregnable defenses had been overcome so easily, while their attempts to minimize American achievements were contradicted by obvious tactical realities. This credibility gap undermined Japanese propaganda effectiveness, while reinforcing American claims about industrial and technological superiority. Long-term confidence and capability perception changes resulting from American amphibious innovations influenced strategic calculations throughout the Pacific theater. Japanese commanders could no longer assume that coral barriers would provide effective protection, forcing them to develop new defensive strategies without adequate resources or time. American planners gained confidence in their ability to assault any Japanese position, creating strategic flexibility that accelerated campaign timelines while reducing operational risks. The immediate war impact of American amphibious capabilities proved decisive in ways that Japanese planners had not anticipated. The ability to assault coral atolls directly eliminated Japanese defensive advantages that had been considered permanent, allowing American forces to advance across the Pacific at unprecedented speed. Specific battles like Tarawa, Saipan, and Iwo Jima demonstrated how American amphibious superiority could overcome even the most determined Japanese resistance through technological and industrial advantages that could not be matched. Specific battles and campaigns where American amphibious capabilities proved decisive revealed the broader strategic impact of technological superiority. The Marshall Islands campaign demonstrated how LVTs could enable rapid island hopping that bypassed Japanese strongpoints while maintaining operational momentum. The Marianas operations showed how amphibious capabilities could support simultaneous assaults that overwhelmed Japanese defensive capacity. Each successful operation reinforced American advantages while exposing Japanese vulnerabilities that could not be corrected. Enemy acknowledgement of American amphibious superiority came through captured documents and post-war testimonials that revealed the psychological impact of technological innovation. Japanese commanders consistently noted their inability to counter American amphibious capabilities effectively, while technical personnel documented the industrial and engineering advantages that made American success possible. This acknowledgement represented more than tactical defeat. It reflected recognition of broader American superiority that influenced strategic calculations throughout the Pacific War. Post-war recognition of American amphibious innovations came from military historians and former enemies who acknowledged the transformational impact of LVT capabilities. Japanese naval officers credited American amphibious technology with fundamentally altering Pacific warfare, while Allied commanders noted how these capabilities had accelerated victory timelines. Historical analysis consistently identified American amphibious superiority as a decisive factor in Pacific victory, demonstrating how industrial capacity could be translated into battlefield advantage. Enemy commanders' post-war assessments provided authoritative recognition of American amphibious superiority. Admiral Somu Toyoda, former commander of the Combined Fleet, acknowledged, "American amphibious capabilities eliminated our defensive advantages and created strategic options that we could not counter. Their ability to assault coral atolls directly made our island fortress strategy obsolete." This assessment from Japan's senior naval commander represented definitive recognition of American technological and industrial superiority. Historical analysis of American amphibious capabilities consistently emphasized their importance in achieving Pacific victory. Military historians noted how LVT technology had solved strategic problems that had seemed insurmountable, while industrial historians documented the manufacturing achievements that made mass production possible. This historical consensus recognized American amphibious capabilities as a decisive factor in Pacific victory, demonstrating how technological innovation could determine strategic outcomes. Technological legacy and influence on future warfare reflected the enduring impact of American amphibious innovations. Post-war military development consistently emphasized amphibious capabilities, with LVT technology providing the foundation for modern amphibious assault vehicles. The engineering principles and manufacturing techniques developed during World War II influenced military technology for decades, demonstrating how wartime innovation could create lasting advantages. What Lieutenant Commander Shibasaki witnessed that November morning represented more than tactical surprise. It was the revelation of American industrial and technological supremacy that would determine Pacific War outcomes. The LVTs crossing Tarawa's coral reef carried more than Marines and equipment. They carried the proof that American innovation and manufacturing capacity could overcome any obstacle that Japanese forces could create. The mathematics of war had been fundamentally altered, and the statistics of production, performance, and operational capability told a story that no amount of Japanese courage or determination could counter. Like and subscribe for more untold stories of American ingenuity and industrial might that changed the course of World War II. Share this video to help others discover how American innovation overcame impossible odds in the Pacific theater.